So today, we're going to take a look at a school in Thailand that's doing something pretty amazing with its science class. It's a program called The Little Scientist's House, and it's built on this really powerful idea. What if kids learned science not from boring old books, but by playing, exploring, and yeah, even messing up a little? Let's dive in. I mean, this is the big question, right? It's not about getting kids to memorize facts for a test. It's about actually nurturing that mindset. That curiosity, that drive to figure things out. How do you actually teach that? Well, as this program shows, the answer isn't sitting quietly in a library. Nope, it's in the noisy, messy, totally hands-on world of play. At the end of the day, it's about learning science by doing science. So, where do you even start a journey like this? Well, the program kicks things off by sparking curiosity, not about, distant stars or deep oceans, but about something much closer to home, themselves, and how they experience the world. It all started with a game. Picture this. It's kind of like pin the tail on the donkey, but with a pot. In the first round, a student gets blindfolded, and their team has to shout directions to guide them. Simple enough. But then, in round two, they add earplugs. Now everything changes. Communication has to be totally reinvented on the spot, through touch, through new signals. It's a bit chaotic, for sure, but there's a real point to it. And that's the key, you see. This wasn't just for fun, it was a direct lesson in what we call sensory awareness. The students got to feel, firsthand, just how much we depend on our sight and hearing to get information about what's around us. By taking those senses away, they had to start thinking critically about information itself. Okay, so after exploring their senses, things got a little more personal. The students basically became detectives, and the mystery they had to solve was hidden in their own hands. They were looking at something they see every single day, but had probably never really looked at before: their fingerprints. And this is where a little bit of biology became the key to the game. They learned to spot the three main patterns: the arch, the loop, and the whorl. After getting their hands dirty with some ink, they started looking at their own prints and figuring out which patterns they had. And here's the beautiful part. After they tried to match a bunch of anonymous fingerprints back to their classmates, they came to this huge scientific conclusion all by themselves. Nobody told them this fact. They discovered it. So, after looking inward at themselves, these little scientists turned their attention outward to the world of nature and engineering right there in the classroom. I mean, look how beautifully simple this experiment is. You take a cabbage leaf, you stick it in some colored water, and you just watch. That's the scientific method, right there in a nutshell. You set something up, you observe what happens, and you write it down. No fancy lab equipment needed, just a bit of patience and a whole lot of curiosity. And this was the big aha moment. The colored dye made the invisible visible. They could literally see this hidden highway inside the plant, watching the water travel from the stem all the way out to the very edges of the leaf. Now that's how you make biology exciting. But they didn't just stop with biology. Oh no. The kids also got to be engineers for a day. Using really simple stuff like styrofoam, straws, and clay, their challenge was to design and build a buoy that could actually float. They were learning about physics and design through pure trial and error. All right, so from the physical world of plants and buoys, the program then shifted into something a little more abstract, exploring the beauty and logic of patterns. This is where science and math really starts to overlap in a cool, creative way. So the teachers gave them this puzzle, and it sounds so simple. Can you draw this little house shape without lifting your pen off the paper and without tracing over the same line twice? It sounds like a drawing game, but it's actually a famous puzzle in a field of math called topology. It's a test of logic, not art. The only rule was one single continuous line. To crack it, you can't just start drawing randomly. You have to plan ahead, you have to think about your path, and you'll probably have to fail a few times before you get it right. It's a full-on problem-solving workout, just disguised as a doodle. Now, it's really easy to just show the shiny, perfect version of how all this works. But what I love about this program is that it's real, and it embraces the messiness of actual learning. So let's take a look at what really happened during some of these activities. Remember that blindfold game? Well, the teacher's note said that at first it was just pure chaos. You had a bunch of kids shouting directions all at once, and the poor blindfolded player was just lost and confused. The lesson wasn't just about senses. It was about figuring out how to work together and communicate clearly. And this is absolutely the most important part. The learning didn't stop when they hit a roadblock. The roadblocks became the lesson. They didn't have enough thermometers? Okay, they learned to manage their time and share resources. Kids started arguing over who gets to go next. They created a fair system by drawing lots. The buoy kept tipping over. They put on their engineering hats and redesigned it. Failure wasn't the end. It was just part of the process. So, after all the games and all the experiments and, yeah, all the chaos, what was the real lesson here? What was the whole point of the little scientist's house? Well, it was never really about knowing the 3 types of fingerprints or how a cabbage leaf works. It was about building this incredible foundation of skills: how to observe the world carefully, how to test an idea, how to work with other people, how to communicate, and how to look at a problem not as a dead end, but as a puzzle just waiting to be solved. And that's the real heart of it, isn't it? The goal wasn't to turn out a bunch of future scientists. It was to raise curious, confident kids who aren't afraid to ask questions, to try something new, to fail, and most importantly, to learn from their mistakes and try again. And that kind of leaves us with one last big question to think about. What if this wasn't just some special program? What if every classroom was a little scientist's house? What could a whole generation of kids taught this way really achieve?